Okay, we're going to continue with our exploration of factoring. And in the first one, we talked about things that are common. This time, we're going to talk about what to do if things are not in common. And these are trinomials. You know, they're trinomials because there are three terms. One, two, three. So three terms. So we have it as a trie. So this is a trinomial. And you must have a coefficient of 1. And that means before the x squared, there can't be anything here or it has to be a hidden number 1. So these all have hidden number 1s. And we'll talk about this case in a minute. Okay, so this trick only works with factoring trinomials with a coefficient of 1. Now, before I deal with this, I want to show you something we've done in the past, and that is a problem like this one. So let's say we have x plus 1 and x minus 2, and then when we multiply this out, we use the distributive property. So we're first going to distribute the x to everything, like so. And then we have to go back and we're going to distribute the 1 to everything, like so. And make sure you keep the signs with it. So this is positive 1, and that's a negative 2. So for the red, we have x times x, which is x squared, and x times negative 2, which is negative 2x. And now we're going to go back and do the green. So we got 1 times x is x, and 1 times negative 2 is negative 2. And now we're going to combine like terms, and these are the only terms that are like. X squared is not alike, so you get x squared. Minus 2 plus 1 is minus 1, so I have minus x minus 2. And that's what we look like over here. So remember, factoring is going in reverse, so we're starting with this, and we want to go backwards up to this. Okay, so our final answers here are going to have a double set of parentheses. That's true for all of these. Okay, so remember, final answers should have a double set of parentheses if these are factorable, and that's an if. They're not always factorable using this method, but we're going to look at the cases. So let's take a look at this. Where did this negative 2 come from? Well, if we look back at it, this negative 2 came from right here, which comes from this arc. So that would be the 1 times negative 2. So this is things that are multiplied together. So when our last terms are multiplied together, you get this negative 2. The other thing we want to look at is this right here, which is a negative 1. It's not the best example because there's a hidden 1 there, but that's a negative 1. And I want to know where that negative 1 came from. Well, it comes from right here, and that came from this arc and this arc right here. And that was because these two things added together give us this negative 1. So the interesting thing is that it has to do with the last numbers and what they are. So here we have the negative 2, ended up there. Here's the 1, ended up there. Remember, this is a hidden 1. And here we have again the negative 1 and negative 2, which formed this number. So when it's multiplied, it's this, but when it's added together, you get the middle term. So we can now undo it. So we know these are multiplied and these are added. So let's see if this works. So the first thing I want to do is find out what numbers multiply to 2. Don't worry about the negative for now. What numbers multiply to 2? Well, 1 times 2 works, and that's basically it. Now I really need a negative, so I need to put a negative somewhere. And if I want my answer to be negative, I need one negative. So I can either put it on the 1, or I can put it on the 2. So these are the only two possibilities. So if this thing is factorable, one of these two things has to be true. If neither one is true, then there's nothing else, because there's no other way to multiply to negative 2. But we just said that it has to add to negative 1. So I look at both cases and see if they add to negative 1. Well, if I go negative 1 plus 2, we get positive 1. So this case does not work. So we're going to cross this case out. Because even though they add to negative, or multiply to negative 2, they do not add to negative 1. So let's look at the second case. 1 minus 2 is negative 1, which is what I'm looking for. So this is the case that we are looking for right here, because they multiply to negative 2 and at the same time they add to negative 1. So when you see this and it works out, then your answer looks like this. Double set of parentheses. The variable goes first. In this case we have an x, whatever variable you have here, and these numbers go second. So if it's positive, you put a plus, and if it's negative, it's a minus. And if we look back at the top, that's exactly what we started with. So this is called factoring a trinomial. Okay, leading coefficient of 1. You cannot do this without a leading coefficient of 1. So let's try it. So here I got another example. I'm going to go back to blue. I got x squared minus 2x minus 8. I'm looking for the last number and things that multiply the last number. Well, we got 1 and 8, and we got 2 and 4. And those are the only possibilities. Again, I want a negative 8, so I need numbers that multiply to negative 8. So either they're going to be negative 1 as the first number, or we can have negatives as the second number. So we have 4 cases to check with. Either it's going to be negative 1 and 8, or 1 and negative 8, negative 2 and 4, or 2 and negative 4. And I don't care if you write both sets out as long as you know that a negative needs to be somewhere. Now I'm looking at the middle term, and the middle term is negative 2, so I need them to add to negative 2. So if I look at this set, I'm going to change color so I can cross things out. It says negative 1 plus 8, that is 7, which is not negative 2. Here I got 1 minus 8, which is negative 7, which is not negative 2, so that's gone. Here I got negative 2 plus 4, which is positive 2, close, but no. Here I got 2 minus 4, which is negative 2. That is what we're looking for, is negative 2. So that's my answer, and I'm going to put it in here. So I get x plus 2 and x minus 4. Now you could always multiply it back out, so let's check. We got x times x is x squared. X times negative 4 is negative 4x. 2 times x is 2x. When we combine those, negative 4x plus 2x, you get negative 2x, which is what we had. And lastly, 2 times negative 4 is negative 8. So indeed, we are back to our original one when you distribute this out. So this is our answer right here. Parentheses x plus 2, another set of parentheses x minus 4. Remember, this is a multiply problem. Let's try this next one. So we got x squared plus 6x minus 7. I'm looking for things that multiply to 7. Good news is there's only one set, 1 and 7. I need a negative, so either I'm going to put the negative on the first, or I'm going to put the negative on the second. I need it to add to 6, so the only way to add to 6 is to use this first set, because 7 minus 1, or negative 1 plus 7, is 6. So we're going to plug those in, x minus 1 and x plus 7. And we're done. There's the answer. Okay, and let's look at this one. So this time I got 18. 18 has several numbers to choose from. I'm going to write them over here. So we got 1 and 18, 2 times 9, and 3 times 6. 4 does not work, 5 does not work, 6 we've already checked. So once we get to a number we've already checked, we're done. So these are the possibilities. I need it to be positive, so they could either be both positive, because 1 times 18 is 18, or they could both be negative. And you got to check all these cases. Now I'm looking at adding, and the middle number is negative 9, because you keep the sign. So this is negative 9. If I need to add to negative 9, if I add two positive numbers up, it will never be negative. So I can immediately cross out these 3 sets, because they have to be negative. I'm looking for a negative 9. Negative 1 and negative 18 is negative 19, so that doesn't work. Negative 2 and negative 9 is negative 11, so that doesn't work. Negative 3 and negative 6 is negative 9, and that's what we're looking for. So there's the answer. We're going to plug them in. X minus 3 and x minus 6. Okay, now this one, we already said we can't do it because this is not a 1. So we'd be tempted to give up. But the very first thing we always have to check for is things that are in common. And if we look through here, I see 2, 14, and 24. There is a 2 in common that I can divide them all by because they're all even. I also look here, and this needs to be a square. I'm not sure if I mentioned that earlier, but this only works for x squareds. Okay, so make sure this is a square. This is a cube, so it would not normally work, but here I got a square, an x squared, and an x. So cubed, squared, and x. This also has an x in common, so we can factor that out. So I'm going to factor out the 2 and the x, and then see what's left behind. And you're going to get x squared. It's 2 times 1 is 2. X times x squared is x to the third. Minus 7. 2 times 7 is 14 with the minus symbol. And I needed x because x times x is x squared. Plus, and then half of 24 is 12. So 2 times 12 is 24. 2 with the x times 1 is x. So that's it. And then I'm going to look at what's inside the parentheses and look to see if I can now factor this, which now we can because it's an x squared with a coefficient of 1. So we're looking for things that multiply to 12. I got 1 and 12, 2 and 6, and 3 and 4. It's positive, so they're all positive or all negative. If I'm looking for a negative 7, they're all going to be negative, so let's put the minus signs on there. And negative 7, that doesn't work because that's negative 13. 6 and 2 is negative 8. 3 and 4 is negative 7, so that's what we're looking for. So inside here, we have x minus 3 and x minus 4, like we did from the top. But now we got to deal with this 2x. All you do is you just drag it along for the ride, and it's down there. And this is our final answer. So our final answer is 2x from the first step, and then parentheses x minus 3, and then parentheses x minus 4. So make sure you watch out for that. So everything you do at the beginning of 12.3 with the things in common can still apply in the trinomials. And remember, to factor a trinomial, it needs to be a 1 as a coefficient, and it must be an x squared. Otherwise, this trick does not work. If you have questions, please make sure you ask.